All right, so now let's look at how we write some of this stuff down. Okay? So whenever we are dealing with relative motion, we generally have three things. We have an object relative to the object it's in, okay? The other thing relative to the ground, and then our object relative to the ground. So let's do an example of right, a boat on water. So the velocity of the boat with respect to the water is how fast the boat would move in calm water. Okay? The velocity of the water with respect to the ground, okay, is how fast the water is moving. And then when you add those vectors together, you get the velocity of the boat with respect to the ground. Okay? Now keep in mind, these pluses here don't just mean addition, they mean vector addition. So if we have something going east and something going off at an angle, okay, we've got to use components or trig to put these things together. Okay. Another common one you run into, right, is plane flying. Right, so you'd have the plane with respect to the wind, and then you'd have the velocity of the wind with respect to the ground, and together they would make the velocity of the plane with respect to the ground. Right, so this is the airspeed that the plane is flying at. The velocity of the wind with respect to the ground is the speed of the wind, and then the velocity of the plane with respect to the ground is the actual path that the plane ends up traveling. Okay? So that's kind of how we frame this. And what you choose for the letters doesn't matter, right? I chose boat, water, and ground, so BWG, or I choose plane, wind, ground. Okay, in the example, it used river and earth, R and E. So what letters you use doesn't matter. Just try to be consistent in a problem. Okay? But you do notice, right, BW plus WG. Okay, so in order for these things to work, right, the middle part here, okay, part of vector notation is these have to match. So BW plus WG gives us BG. PW plus WG, so these W's on the inside are connected. Okay? So that means we can add them together. Right? So if you had, right, it's the equivalent of like I had vector AB plus vector BC. The end result is that I get vector AC. Right? So if I had, right, AB and I had BC, the end result I get is AC. So that's all that's going on here. So all the math is going to be 2D vectors. So the same kind of math that you've seen before. The trick to these ones is setting them up properly. That's what makes them tricky. Sometimes you have to think about a few extra steps, but most of the math is just taking two vectors and adding them together.